together after they collided. Okay, let's have some sample problems. So let's remember the formula. F change in t equals to m change in velocity. Impulse is equal to momentum change. So sa mga sample problems na susunod, and also here, ang gagawin natin, meron tayong given na dalawang case A and B. And we would determine kung aling case mas malaki yung velocity change, pagbabago sa velocity, mas malaki yung acceleration, malaki yung momentum, and malaki yung impulse. Hopefully, we can understand more the theorem through these sample problems. Okay, let's read the situation. So, the ball ay hinataw mo dun sa pader, di ba? So, siguro, or of course, the ball is elastic, so nag-bounce back siya. So, from 10 meters, naging bumagal siya, 5 meters per second. And then in the case, letter B, it was 30 meters per second. And then after it hit the wall and it bounced off the wall, naging 28 meters per second na lang siya. Okay? O, pwede natin i-compute ngayon, di ba? Yung velocity change. Kasi may final ako saka may initial ako. So, change in velocity is equal to final minus initial. Case A muna po tayo, 5 meters per second minus 10 meters per second. So, we will get, negative din yung di ba? Remember, vector, nagmamatter in direction. Negative kasi pupuntang kaliwa. So, negative 15 meters per second. Don't mind the negative sign. That only means na naging pupunta na siya sa kaliwa. Right here, sorry, minus dapat yun. Final is 28 negative minus 30 meter per second. Oh, ang laki pala. 58 meter per second. Also negative because the resulting scenario is magiging papunta siya sa kaliwa. So, saan mas malaki? Makita naman natin, sa 58. Laki nung velocity change dito. So, definitely, in terms of velocity change, sa case B tayo, diba? Greater ang change in velocity here. What is acceleration pa, diba? Acceleration is nothing but change in velocity over change in time. So, assuming na pares lang naman sila ng haba ng contact with the wall, the length of time na nag-contact sila with the wall, kita natin na mas malaki talaga yung velocity change sa case B. So, therefore, dito din mas malaki yung acceleration or the change in velocity. And then, according to the theorem, di ba, these two terms are equal, impulse and momentum change. O, pag lumaki yung velocity change ko dito, di lalaki din yung impulse ko. Di ba? Or actually, first, meron pala tayong momentum change na dapat isolve. Di ba momentum change ay mass times change in velocity? Saan ba mas malaki yung change in velocity? Kasi pag minultiply ko sa mass yun na yung momentum change, di ba? Yun na yung momentum. So actually, case B din. And kung alin ang mas malaking momentum change, dahil equal ang momentum change sa impulse, case B din yung answer. Kasi equal lang naman tong dalawa. Okay? Let's have another case. So, this is a velocity time graph. Makukuha natin, di ba, yung final and initial velocity dito. First, the object was traveling at 5 meters per second. There was a change in velocity, and then it became negative 3 meter per second. In the case of this one, it was first traveling at 3 meter per second, and then at negative 1 meter per second. So, VF here is negative 3 meter per second. VI is 5 meter per second. Here, VF is negative 1 meter per second. BI is 3 meter per second. So, let's solve for the change in V. Change in V is VF minus VI. VF is negative 3, negative 5, negative 8 meter per second. Here, negative 4 meter per second. O, kita natin, negative, dito tayo. Kita man natin din sa graph, no? Ang laki ng agwat ng dalawang straight line. So, in case A, malaki yung velocity change. Dahil acceleration is change in velocity over time, dito din malaki yung acceleration. Since impulse is mass times v, dito din malaki yung since momentum is mass times v, dito din malaki yung momentum. And dahil momentum is equal to impulse, case A din tayo doon. Impulse is also greater in case A. Okay? Determine in which case is the velocity change, acceleration, momentum change, and impulse greater. That diagram naman ito, no? Una, pumunta yung object doon sa wall. Tapos, ito nangyari after nag-bounce. Kita natin na constant. Papunta sa kanan, papunta sa wall, and away from wall. Kasi same ang spaces between the dots. But, we can see that, although dito sa bouncing sa wall, hitting the wall part, same ang velocity nila, di ba? But after it hit the wall and bounce off, alin na mas mabilis? Siyempre, ito nasa case B, di ba? Kasi mas malalaki yung agwat. Dito, dikit-dikit yung agwat. Ibig sabihin, this is slower. So, therefore, saan mas malaki yung pagbabago? Sa velocity. Tingin ka sa spaces in between them. Alin yung from this, ganun na lang yung space doon, dikit-dikit na niya. From this space, nagdikit-dikit pero hindi masyado as compared with case A. So therefore, mas malaki ang velocity change dito sa case A. Siyempre, malaki din ang acceleration doon. By definition, di ba? Dahil m times v is momentum, dito malaki yung momentum change. Since this is momentum change is equal to impulse, dito din malaki yung impulse. Ganun lang po. Okay? Okay, let's fill in the table. Of course, we're not going to fill in all of them. Parang puzzle ito, no? May force, may time, may impulse. I forgot actually to tell you the unit of impulse. But you can see it here. Since impulse is force times time is impulse, edi Newton times second. So, NS. Dito naman sa kabila, may kita mo, mass times velocity is equal to momentum change. Mass times velocity change, or change in velocity will be equal to the change in momentum. Okay, so ganito pala yun. Ganito mo siya babasahin. Itong A and B will result to C. Itong D and E will result to F. Pinag-meet sila dyan sa gitna kasi dapat equal sila, di ba? C and F have to be equal based on the theorem that we have. Mag-solve tayo sa A. Paano ma-solve ang A? Di ba ang formula mo ay F times change in T equals mass times change in V. Impulse is F change in T. Momentum change is M change in V. Paano ko ma-solve yung Paano ko ma-solve yung force? Wala akong impulse. Papunta muna ako dito sa kabila. Ma-solve ko itong momentum change kasi meron akong both mass and velocity change. Pag multiplying ko lang yun, diba? So, makakuha ako sa C ng paano ko i-solve ang C? Mass times change in V. Mass is 10 kilogram. Change in velocity is negative 4 meter per second. So, C is negative 40 kilogram meter per second. Based on the theorem, C and F or C and B will be equal to each other kasi momentum change will be equal to the impulse. Kung ano lang yung naganap na impulse, that will also be the magaganap na momentum change. So, equal to each other. I can solve for the I can solve for the force, letter A, diba? So, letter A, I have impulse now. By the way, bigla ako nagtaka. Kasi, diba? Sabi ko, ang unit ng ano ay N times S. Paano ko palalabasan yun dito? Sa kilogram meter per second. Di ba ang N ay kilogram meter per second squared. Pag naglagay ako dito ng S on both sides of the equation, ano mangyayari? Makakancel ko yung isang S. So, yun na. Yun na siya. Kilogram meter per second. So, yung N times S pala equal nga pala yun sa kilogram meter per second, by the way. Okay? Okay. Let's solve for A. Paano ko makuha yung A? Oh, yun yung force. Yun yung hanap ko. Equals impulse. But impulse is negative 40 kilogram. Oh, gawin na natin Newton times seconds kasi impulse na tayo eh. Newton times seconds. Time is, ulit ng time, 0.010 seconds times F. Dapat i-divide ko siya both sides by 0.010 seconds. 0.010 seconds. I will cancel the seconds. What will I get? I will cancel the 0.010 seconds. Oh, what will I get? Negative 40 divided by 0.010 is actually 400 newtons. May negative siya. Okay. Okay, you can answer the rest. Okay? Sige nga, number 2, how will you do the analogy? Punta ka muna dun sa part ng na konti lang. Na-given na yung dalawang variable. Ito, given na yung dalawang variable, di ba? You can already get D. But actually, given ka ng impulse. So, equal yun sa E. Okay? Makukuha mo itong E, multiply mo sa 10. Hindi mo yung multiply. I-divide mo sa M. Makukuha mo yung F. Ganun lang yan. Okay, punta ka muna sa part na masasolve mo agad. And then, itong dalawa na to, lagi yang equal to each other. Okay? Okay. I will see you on the next section.